We now discuss the solution of a problem from the section Statistics and Probability. This problem is related to the probability of 2 by 2 matrices with the entries which are the prime numbers, the first 10 prime numbers. The entries are the first prime numbers and a related question. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is the probability that a randomly chosen 2 by 2 matrix with all the entries from the set of first 10 primes is singular is equal to. We are given 4 options. Here are the 4 options, option A, B, C and D. Required to find the probability that a randomly chosen 2 by 2 matrix with the entries coming from the set of the first 10 primes and the probability that a randomly chosen 2 by 2 matrix with this condition is singular. That probability that it is singular is equal to. We now discuss the solution of the problem in detail. Let capital P be the set of the first 10 prime numbers. P is equal to the set consisting of 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. Let S is the sample space in this case, is equal to the set of all 2 by 2 matrices with first row A, B, C, D, where the entries A, B, C, D belongs to capital P, where P is the set of first 10 primes. Now, the n of S, the order of S is equal to 10 into 10 into 10 into 10, that is equal to 10 to the power of 4. Why? Each entry, that is A, B, C, D, have 10 choices. Then for A 10, for B 10, for C 10, for D 10, use the product rule. No condition on A, B, C, D, no condition. So this is 10 to the power of 4 since each entry of the matrix, that is A, B, C, D, has 10 choices. So the order of the sample space is 10 to the power of 4. Now what is the event? Let E be the event, that is the set of all A belongs to S such that determinant of A is equal to 0, that is A is a singular. That is the set of all A is equal to A, B, C, D, first row A, B, second row C, D, such that the determinant of A is 0. That means AD minus BC is equal to 0. That is AD is equal to BC, where A, B, C, D belongs to B. So required to find. So then they required to find the probability, the given probability, that is the required probability is n of E by n of S. So n of S we know. So our job is to find n of E. Agree. That we do in the next slide. So we have E given the set and we do 4 cases. First case, suppose that all the entries of A are distinct. That means all A, B, C, D are distinct. And AD is equal to BC means C is equal to AD by B. Belongs to P. So C belongs to P and thereby AD by B belongs to P. AD by B belongs to P means either B divides A or B divides D. And this is not true. In the set of first 10 natural numbers, no one divides no one. So, and this is not true. So, no matrix of E satisfies the condition, that is the singularity condition, that is AD is equal to BC in this case. So, Case 2. Suppose 3 entries of A are distinct. Say A, B, C are distinct and D depends on A, B, C. So D belongs to the set consisting of A, B, C. Subcase A. If D is equal to A, if D is equal to A, AD is equal to BC, D is equal to A means AD will be A square is equal to BC. That means BAC are in GP. This is not true. In the first 10 prime numbers, no 3 are in GP. This is not true. Take the subcase D is equal to B. If D is equal to B, then AD is equal to BC will become AB is equal to BC, and cancelling B on both sides, and you will get A is equal to C, a contradiction because A, B, C are distinct. Subcase C, if D is equal to C, if D is equal to C, AD is equal to BC, AD is equal to BC will give you D is equal to C, AC is equal to BC, cancelling C you will get A is equal to B, a contradiction because A, B, C are distinct. So no matrix of E satisfies the condition, that is the singularity condition, in this case, that means in the case 2. So we consider the next case in the next slide. Case 3. Suppose 2 entries of A are distinct. Say AD are distinct and BC belongs to the set consisting of AD. A. If B is equal to C is equal to A, if B is equal to C is equal to A, AD is equal to BC will give you AD is equal to BC, B is equal to C is equal to A, AD is equal to A square, and cancelling A on both sides, A is equal to D, which is a contradiction. A and D are distinct. Subcase B, if B is equal to C is equal to D, then AD is equal to BC will give you AD is equal to D square, cancelling D you will get A is equal to D, a contradiction again. And subcase C, if B is equal to A, C is equal to D, then AD is equal to BC. AD is equal to BC. The condition is satisfied. So let us collect all the matrices with this condition. Let E1 be the set of all 2 by 2 matrices A, B, C, D such that B is equal to A, C is equal to D. That is the set of all 2 by 2 matrices. So 2 by 2 matrices A, B is A, C is D, D is D. So AD is equal to AD and AD belongs to P, A not equal to D. Now the question is how many such matrices will be there. So note that A can take 10 choices and having chosen A, D has 9 choices. Since A not equal to D, so first choose A in 10 ways. Having chosen A, D has 9 choices because A not equal to D. Therefore, N of E by product rule, N of E1 by product rule is 10 into 9 by product rule. So N of E1 is 90. Now take the next case, D. If B is equal to D and C is equal to A, then AD is equal to BC is satisfied. The condition is satisfied. Therefore, let E2 is the set of all 2 by 2 matrices. A is equal to A, B, C, D, where B is equal to D, C is equal to A. So this is AD. So where AD belongs to P, A not equal to D. Like the above, it has 90 choices. So notice that A has 10 choices. Having chosen A, D has 9 choices since A not equal to D. Therefore, by product rule, N of E2 is equal to 10 into 9, 90. So So thus we have found this one. We move to the next case. Fourth case. Suppose that all entries of A are equal. That is B is equal to C is equal to D is equal to A. So each one is A. Then AD is equal to BC. The condition is satisfied. The singularity is satisfied. So let E3 be the set of all 2 by 2 matrices. Capital A is equal to A belongs to P. Now A has 10 choices. Therefore n of E3 will be 10. So now n of E3 is equal to 10 since A has 10 choices. So thus all the four cases we have considered. Now let us see, summarizing all the above cases, we get E is equal to the set of all A belongs to S such that determinant of A is equal to 0. That is equal to the set of all 2 by 2 matrices A, B, C, D, where A, B, C, D belongs to B, P, and singularity will give you AD is equal to BC. And this is equal to E1 union E2 union E3. So these are the cases what we have enumerated. And note down that E1, E2, E3 are pairwise disjoint. Therefore, n of E is equal to n of E1 plus n of E2 plus n of E3 because E1, E2, E3 are pairwise disjoint. So, and n of E1 is 90, n of E2 is 90, n of E3 is 10, 190. Now, the required probability is n of E by n of S. N of E is 190, n of the sample space is 10 to the power of 4 and 0, 0 cancels, it will be 19 by 10 cube. Let's look at our options. Our answer 19 by 10 cube appears against option C. Therefore, the answer to this question is option C. That is the detailed discussion of the solution of the problem from the section statistics and probability, and the problem is on the probability of 2 by 2 matrices with the entries of the first 10 prime numbers. I am sure that you have understood the solution of this problem and I wish you all the best. Thank you.